Very good evening, Harika. Okay, so I guess we have to start now. So first of all, wishing you very good evening, everyone, and it's going to be our fourth session on the mind chapter. So let's continue. So as you already know in the previous class, we discussed about the rearrangement reactions there. So we already covered the rearrangement reaction of the amine there. So basically, we already finished the preparation of the amine there. So in today's class, the topic of discussion is going to be the chemical property of amine. Okay. So let's just talk about that is the reactivity of amine, like how about the reactivity, how it is going to react. So reactivity of amine. Okay, so as you already know that amine has a lone pair, so just because of the lone pair it is a very good Lewis base. Okay, and this is some R group, let's say. So in this case, there's a two kind of point we can apply. That the point number one, if you're observing something that nitrogen is more electronegative, so it's a partial negative, it's a partial positive, so this bond is a kind of polar bond, right? So it's a polar bond simply. Okay, and the second choice, maybe the lone pair can also participate in a reaction. So this is how we are having different kind of scenario there. So let's see actually how it is going to react. So in this case, there is a two kind of choice we are having. The choice number one, that this amine can react in a two-way. That is the point number one. Maybe it is behaving like a base, as a base. If you remember, we discussed so many time in the previous classes that amine is a very good base. So as a base, or the second choice, maybe as a nucleophile there. Okay, so as a nucleophile. So let's discuss about both the reaction one by one. And I hope this point is clear that it's a polar bond and this is responsible for kind of reactivity there. So let's continue that how about the reaction. So the point number one, if amine act like a base, okay? The point number one, if amine behaving like a base. So let's see what is happening. That nitrogen has a lone pair, okay, this is how. And some H positive present there, okay, let's say some HA be like acid. So it is behaving like a base here and it is behaving like a simply acid here. So nitrogen has a lone pair, lone pair simply attack here, and just because of this O negative simply remove, we are getting N. Okay, it means that is the fourth thing connected with the nitrogen, and we are end with the ammonium ion, right? Like this. So, like if you to draw in the form of okay, this hydrogen is extra part, and let me just consider this is a wedge position, and this is a dash position. So same, that is this is a desk position and this is a some wedge position there. So like this is the point that this is how a mine behaving like a base. Okay, normally a base there. Now let's see the point number one, if amine behaving like a nucleophile. Okay, so this is a point number one and this is a point number two, that is if amine behaving like a nucleophile. Okay, so nucleophile, this is the point number one and this is the second one. So let's see how. So for example, that we are having a kind of nitrogen and the same one is wedge position, one is test position like this. And let's suppose some are CH2 and Br is there. This time it is behaving like a nucleophile. So what is the point? Like how to observe? Look at this. Nitrogen has a lone pair. This is simply attack here. And bromine is a very good living group. It's going to leave. Okay. So it means in this case, like how about the reaction that we are getting nitrogen? Still nitrogen form four bond, but what is the different part here? This time this is CH2 and R connected here. Nitrogen still positive charge, okay? And bromine simply leave there. So if you're observing something, what is the difference between above and below reaction there? So if you're observing that hydrogen connected here, so it's normally acid base reaction. Other than the hydrogen, anything connected here, so it's become that is a nitrogen or ammonia behaving like a base there. Okay, so this is like how the ammonia reacted in a two-way, like a base, like a nucleophile as well. Okay, so this is a kind of introduction. That's it. Now let's discuss about that kind of chart. Okay, so like how chemical property of amine. So just try to observe this. We are going to discuss one by one the complete thing. So the chemical property of amine. Chemical property of amine we are going to discuss. So in this case, that the point number one, if it is behaving like a base, as a base, we just discuss how like what if it is behaving like a base. Okay, the point number two, if it is behaving like a nucleophile, as a nucleophile, and in the same point, if it is behaving like a nucleophile, it is further classified into the next part, that is alkylation. Okay, it means something is connected with the addition of alkyl. If you're observing something like this is addition of alkyl, right? So alkylation kind of thing. And the point number two, that is maybe it is behaving like acylation, so it's become acyl. Okay, don't worry, we are discussing all these things one by one. And then one of the famous one, that is a carbylamine. Okay, it's really important test for the amine chapter, that is a carbamyl reaction there. Okay, and the next is what reaction with nitrous acid. If you remember the haloalkane and haloarine chapter, there we discuss about the formation of BDC, that is a benzene diazonium chloride, diazonium salt. So there we're using nitrous acid. Okay, so it's a nitrous acid reaction with nitrous acid. And the last one, that reaction with sulfonyl chloride. Okay, so reaction with, that is sulfonyl chloride. So we are going to discuss all these point one by one. Okay, sulfonyl chloride. Okay. So like first one is alkylation, then acylation, then carbylamine reaction, then reaction with nitrous acid, and then reaction with sulfonyl chloride. Okay, so this is how it's behaving like a two part. That is, one is a base, one is a nucleophile. Now let's see the third part. Okay, this is the another point that when we are going to discuss about the benzene azodides. Okay, so it's reaction with aniline. Okay, reaction with aniline. So how about the reaction with aniline? In the reaction with in aniline part, that same, bromination, hallucination, Friedel-Crafts acylation, alkylation, same thing. Okay, so reaction with aniline, what is the point we're going to discuss here? That is electrophilic substitution reaction there. Okay, like this is a overview what we are going to discuss in the next slide. Okay, so base part is already covered, nucleophile general part is clear, right? So now let's discuss one by one. First of all, alkylation, then acylation. This is how we are going to move. So let's just continue. Let's just first talk about that the point number one, if it is behaving like a alkylation. Okay, and before moving further, since we are talking about the basicity of the amine system, right? And in the previous class that I assigned you a question, and this was the question. Okay, so basicity be like how to check it for the basicity, right? If I remember, I guess this is the question. Yeah, this is the question. So this question I assigned you. Anyone have you solved this question or not? Question ask about which of the following is not behaving like a base. It's a double bond. Okay. So number be like this is a first carbon, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. Yes, please. Anyone have you solved about this question? Question ask about that which of the following which doesn't contribute to basicity. It means simply that on which nitrogen lone pair is not available for a bonding. So options are like N9, option B it is N3 position, option C it is N1 position, and option number D it is a N7 position. Yes, anyone? 9. Yes, Neharika, very good. So answer is going to be the 9. So question be like why 9 is the correct answer? Yes, definitely 9 is the correct answer. But question be like why? Why? There is anything. Okay, so let's try to understand that why in N9. So observe this. Look at this. This nitrogen has a lone pair. Okay, this nitrogen has a lone pair. So if you are observing that in this case, this nitrogen lone pair participate here in the resonance, the point number one, and the same, that is the some lone pair participating here. So you can say that is the lone pair present on this nitrogen is not available for donation because they are the lone pair participating in a two type, right? That is it's a kind of cross conjugated system. Okay, hence the lone pair on the 9 and 9 position is not available for bonding, and the correct answer for this question is going to be the 9 there. So if we are using this part as a base, okay, so same like we discuss in our 11th class GOC topic that basicity. So how to discuss about the basicity? That is the basicity is directly proportional to the electron donating group. It is inversely proportional to the electron withdrawing group. Donating be like you can say plus M group, plus I group, plus H group, and how about the this? That is a minus I, minus M, and minus H effect is there. Okay, so same that if you remember, okay, for example, let's try to solve a question. How that let's suppose this is a aniline, okay, this is NH2, this is A, okay, and this is NH2. Let's just suppose some CH3 group is connected here, so A and B. So can you just tell me which of the following is a very good base between A and B? Which of the following is a base, good base? A or B? Yes, please. Okay, Niharika, it means A is the good base. Okay. So in this case, look at this. Nitrogen has a lone pair, nitrogen has a lone pair. Both is the common part, right? So now the question be like, what is base? Base is a proton donor. So in this case, look at this. That benzene is a common. But is the extra point? CH3 group. CH3 is behaving like electron donating group. So what is the function of the electron donating group? It start giving the electron density to the benzene ring, okay, like this. So just because of the CH3 group, just because of the electron donating group, okay, and it is behaving like plus H and okay plus H group here, and this is how it's increasing the electron density on a benzene. So you can say the lone pair on this nitrogen is much more available for the bonding as compared to the A. Okay, so the correct answer for this question, that is A is a strong base over the B. Sorry, B is a strong base over the A. Okay, so is this point clear, Niharika? That is which one is a good base? That is B is a good base as compared to the A. Okay, so this is how you can proceed. Okay then, so basicity part is covered now. Now let's go with the second one, that is alkylation part, right? So let's discuss about the alkylation. Okay, so alkylation is very simple. The first one we're discussing now, that is alkylation. Actually, all these things are just a repeated part of the previous classes. Okay, so alkylation. So how about the alkylation? Let's suppose we are having some CH3 and NH2. Okay, and plus that is a CH3, CH2 and Br. So nitrogen lone pair. Okay, nitrogen simply attack here and this bromine is going to leave the molecule. So basically what we are end up there, that is a CH3, CH2, and nitrogen combined here, and this is a CH3 there, and plus that is bromine is going to leave. Br negative, and still this is H2, and just because of the extra bond nitrogen achieve a positive charge. Okay, and in the second step, that if I'm using OH negative, what is the use of this extra OH? OH is just going to abstract the hydrogen from this nitrogen. Okay, so let me write how. This is extra hydrogen just because of the like this. Okay, and there's a positive charge, so OH is going to abstract this OH is going to abstract this hydrogen from here like this. Okay, that's it. So let me write quickly the answer, final answer. So hence at the end we are end with CH3, CH2 and NH, and this is a CH3. So what is this? It's a secondary amine, right? So this is normally alkylation of the amine. Simple. Hi Sakti. Okay, then. So that's done. Now let's see the second one, that is acylation part. Acylation, you already know. Okay, let me just tell you how you already know. So let's just talk about the acylation part. So in the acylation part, we are going to add acyl. So let's see, that is if you are having RNH2. Okay, it can be like R aryl can be there, alkyl can be there. So if I'm using RCOCl, let me just write in a decent way so that you can get my point. That is RCO and this is Cl. So you know what is going to happen in this case? The Cl is replaced. Okay, so let's see what is the next thing, that this is RCO. Okay, and let's suppose this RNH2. So this RNH2 is going to combine here like this. Let's just suppose this is some R dash. So this is how it's look like. Okay, so this is basically the thing. If you remember, we already covered in the chapter, the previous one, alcohol and phenol and sorry, not aldehyde ketone and carboxylic acid, previous chapter. And then again, if I'm using R, CO are still there. Again, that is one portion is going to leave, okay? You know that every time, like in this case, Cl is replaced. In this case, this CO part is replaced. Okay, let me just highlight that this is going to replace here. Similarly, that we are going to replace this here. And again, that is the CO. Okay, like no need to write every time. This is simply the same thing we are getting. Or the case number th three, that if I'm using a kind of ester. Okay, this is ester there. Same again, that is this is going to release, and in place of this, there is a again NHR dash is going to combine. Okay, this is simple sorted acylation. It means that the NH2 is added with the acyl. You know what this is? This group is known as acyl group. Acyl group. So it's a acylation simply. Mechanism important, nothing is important. Just simply remember that how to proceed with the reaction. Okay, this is done with the acylation. Now, in this case, okay, so let me just write the side product as well. Okay, wait, I'm using a different pan. Like how about the, okay, in this case, the side product is HCl. Okay, if you're not getting, let me just explain how. So in this case, this is our CO and Cl. Okay, this is our NH and a hydrogen. Okay, so this is the side product, that is HCl. Okay, and these two combine. So HCl is a side product. Okay, so let me just write that in the reaction number one, side product is HCl. In the reaction number two, okay, in the reaction number two, again, how to proceed with the reaction number two? So you know, we are having a ether or anhydride. So again, that how to proceed. This is O, CO, and this is R. So you know, hydrogen is combined here. So what we are end up there, basically acid is the kind of side product. Okay, so in this case, that okay, RCOH is the side product, and in this case, what is the side product? That is ROH. Similarly, hydrogen is going to combine. So you know, in this reaction one, if you want to increase the rate of reaction, I guess we discussed this point already so many times. If I'm using acyl chloride for the preparation of anything, and if I'm using pyridine, let me just highlight how. That is in this reaction, if this is R NH2 and this is our CO Cl there. Okay, so this reaction is actually at equilibrium, and then this R NH, this is combined with CO and R. Okay, let me just use R dash, and then plus HCl release there. So in this case, if I'm using pyridine, okay, if you want to increase the rate of reaction, and if I'm using pyridine, so let's see what is going to happen in this case. That is, pyridine has a lone pair. Okay, pyridine is a very good base here. So pyridine is going to abstract the hydrogen from the HCl, or you can say it start consuming the HCl from the product side. So let's see actually what is happening, that we are end up with the pyridinium chloride. Okay, that hydrogen simply combined here just because of the positive charge on a nitrogen, and chlorine act like a counter ion. So just try to observe that if you're observing, that is we are moving from reactant, okay, reactant to the product side, and basically due to the addition of the pyridine, the product concentration start decreasing. Okay, I'm repeating again, that is due to the addition of the pyridine, the product concentration start decreasing, and then that we are going to apply, that is a Lee Chatelier principle. So according to this principle, what is going to happen there, that if the concentration of the product start decreasing, so equilibrium automatically favor the product side, so more product we are getting. So simple sorted, if you want to increase the rate of a reaction, just add a little bit amount of pyridine there and it start consuming HCl and reaction rate automatically increases. Okay, so this is basic point we already know. Okay, I guess this pyridine topic we already covered earlier in the previous chapter. Okay then, so that's it. Now let's talk about a special type. Okay, in acylation there is a particular reaction and for which we're using a name. So let's talk about a naming reaction for the acylation, that is a Scotton Bowman reaction. Okay, it's not a rocket science, it's actually easy, same. Okay, that we are just giving the name. Okay, otherwise reaction is the same. So it's a, that is a Scotton Bowman reaction. Okay, so same like every time, like the previous cases, that in this case, what is the reactant or what is the substrate? So same you can use either this or that is the aromatic aniline. Okay, this is a substrate. And reagent is what? That is RCOCl. So wait, acylation, if we can go with the acid chloride, so it means the same thing. Yeah, it's a base. Okay, and what will be the final product? Final product is going to be the amide. Okay, so if you're observing something, let me just move again. Okay, this, although in this case we're using this R, so it's this group is basically the amide, amide, it's amide, so it's amide group only, so we are getting amide only. Anyway, so when we're particularly using that acyl chloride for the acylation, so the name of the reaction become that is a Scotton Bowman reaction. Okay, so let's just talk about same, if reaction is there, general reaction, then mechanism. So general reaction we just discussed, although, but let me just write one more time. How about the general reaction? We are using some RNH2 and this is R, CO, Cl. In the presence of some base, we are getting R, CO, and NH, and this is some R. So let's say this is some R dash and R dash. So this is a kind of general reaction for a Scotton Bowman reaction. Okay, yes, you're right, Shiva. That is the benzoylation is there. So this is a general reaction now. Now let's discuss about mechanism here, like how to go with the mechanism. Okay, let me just write example as well, right? So although no need to do this, but still example. So how about the example? Let's suppose I'm using CH3. Okay, this is CH2 and this is a kind of amine, and I guess you already know it's primary amine. And then again, it's a CH3, CO and Cl. Same, both combine. It, the reaction is at equilibrium. We just discussed about the pyridine case. Okay, so it's a CH3, CH2 and nitrogen, hydrogen. Okay, the nitrogen is sandwich here and then CO and the CH3. So this is a final product in this case we are getting. Okay, you can just simply apply the shortcut as well. So shortcut, okay, although in this case we can't apply, like chlorine combined with this hydrogen, one hydrogen. So HCl is going to release, right? But like this is how, it's a kind of shortcut. Just add them. Okay, whatever be the product like HCl, acid or the ROH. Okay, this is how we can apply. Now, let's see the same thing, that typical mechanism. So let's just talk about the mechanism part. You can write in a single line or you can use the proper naming and everything. So how about the mechanism? So like every time, that is a step number one. Again, you can skip all these things. You can directly use the mechanism. So the step number one, that is the attack of nucleophile. Okay, attack of nucleophile on primary and secondary amine. Okay, so I guess something is clear for you, that in this case we can't use tertiary amine. Okay, we how to, we can't use, just think about it. Why? If let's suppose that nitrogen is connected with 3R and nitrogen has a lone pair, and then I'm using R, COCl is there. So basically it is attacking here. Okay, this bond open and this is of the bond closing. Okay, so what we are getting, that R, CO, and then N, and N is already connected with 3. So this is positively charged spaces. It's not amide. Okay, it's not amide. So we can't use tertiary amine. Okay, be noted, this reaction is only applicable for primary or secondary amine, not for the secondary tertiary amine, because tertiary amine, after once it's adding with the CO there is a formation of four bond on a nitrogen and not stable, or like this is not the reaction. Amide, this is not the amide. Okay, so that's why tertiary is not applicable. Anyway, now let's see the step number one. So what is the step number one? Nucleophilic attack on a primary or secondary amine. Okay, let's see how. This is RNH2. Okay, nitrogen has a lone pair plus that R, CO, and Cl. Okay, this is the step number one. So in this case, that this is attacking here. Okay, I guess you already know the partial bond, partial negative, partial positive. So this carbon is the electrophilic center. Okay, and this is behaving like a nucleophile. Okay, nucleophile electrophilic simple reaction is going to happen. And then what is the next step then? This is how the bond open up. Okay, so next step that we are ready. This is our NH. Okay, so let me just write the H be like this, and this is a positively charged. And this is a CO negative bond open up. This is chlorine, and this is R is there. Okay, so this is the point number one. And in this case, we are using a base. We're using OH. OH is there. Okay, let's just use the base part later. Okay, first of all, we are ready that this thing, nucleophilic attack, that is behaving like a nucleophile. Now let's see the step number two, living group. Okay, leaving of the living group. So let's see, that is the step number two. So what is the step number two? That is the removal of living group. So removal of living group to give amide. Okay, so again, this is R N hydrogen positively charged, and this is O negative, this is Cl negative, and this is Mr, right? So look at this, that this O negative attack here and this chlorine leave. So what is it? It's a living group. It's going to leave. Yes, it's going to leave. So next, that R Cl is automatically removed, and this N still combined with two hydrogen and the CO. Okay, and this is R positively charged. We're using a kind of base in this case, right? So what is the use? That if I'm using OH negative, it is going to abstract, and this is how the bond simply break, and then there is a formation of NCO and R. So this is the final product which we want. Really, this is amide. So it's a Scotton-Bowman reaction. Okay, it's very easy mechanism. Very good evening, only study. Okay, if you have to compare with the at least the previous classes mechanism, so it's look decent as compared to the previous one. Okay, you can go with a single step, directly add and then remove the thing. Okay, it's totally your choice. Okay, so this is all for the silation, and every time you can apply the shortcut. Now let's see a kind of question. Okay, because Shiva mentioned some point that is benzoyl, that is the benzoylation. So let me explain that part as well. So this is a question. I'm using CH3 and this is NH2 plus this is CO and this is Cl. Okay, and in this case I'm using pyridine. Okay, base, some kind of base, and let's see what is going to happen. If you're noting something like let me just write hydrogen be like this way. So observe this, chlorine is going to combine with the hydrogen simply. So it means HCl is removing simply, right? And then what is happening? What is the product? The product is benzene is already there. Okay, and this carbon, this is a CO, and this NH part is simply connected here like this is a final product. And do you know that what is the name for this reaction? So this is a typically that benzoylation. So it's a benzoylation. This special reaction, if I'm using that is the benzyl chloride, okay, benzene, sorry, acyl chloride, and this special is the benzene. Okay, it can be changed, but it is same. Okay, if we are using benzene with the COCl group, so the name of the reaction become that is the benzoylation. Okay, benzoylation. It's a kind of name. Simply, you can consider it to be like a separate naming reaction, or like leave that be like this only. It's okay. Benzo, benzoylation. Okay, this is all for this cotton bomber. Now let's see some important kind of conversion for you. Okay, just a kind of question, just let me know. This is a question. I want to convert this benzene, okay, into this. Anyone, can you just suggest me some kind of way? This NH2. I want to convert a benzene into aniline. How to proceed here? Yes, please. Anyone? How to solve this question? What should I do? How to convert a benzene into a aniline? Okay, because this is a most common type of conversion, you can say. Benzene, this is my aniline there. So benzene to aniline. Okay, sorry. This is the reaction. Nitrogen followed by the SNSL. Very good, Shiva. Okay, so what is the point number one? Okay, remember electrophilic substitution, reaction, nitration. So in this benzene, if I am using HNO3 plus H2SO4, or in short, what is the name of reaction? This is nothing. This is simply a nitration reaction there. So what is going to happen? That there is a formation of nitrobenzene, and previous class we discussed about three method, that is how to convert a nitrobenzene into the aniline. So the step method number one, we can use any metal plus acid, SnCl you can use, FeHCl you can use, or even catalytic hydrogenation you can use, platinum nickel. Okay, so this is how we are getting. Simply that so many conversion, so many step, or so many method, you can apply any method there. Okay, so SN you can use, Fe you can use, H2PD or catalytic hydrogenation you can use. It's totally your choice. Okay, cool. It's easy now. Okay, so this is a conversion. Again, no, conversion is also important. I want to convert. Wait. I want to convert this into this. So what should I use? So let's just count the number first of all. That is a 1 carbon, 2 carbon, 3 carbon, 4 carbon, and a 5 carbon. In this case, 1 carbon, 2 carbon, 3 carbon. Okay, wait. That is from here to here. We are basically having 2 less carbon. We are just starting with the 5 and now we are end up with only 3 there. So what is this? So something is weird. We have to change. Remember in the previous class, I just told you about that. Be noted. If you want one carbon less, there is a one of the famous rearrangement. Which kind of rearrangement we are going to use here? Anyone recall the previous class if you know? A rearrangement where we are getting a less number of carbon, or you can say in every rearrangement basically, right? So think about it. Okay, 1 minute for you. Don't worry, I will explain, but just think about it. No idea. Okay. So, okay, just think about it. First of all, okay, I know one thing. Okay, if somehow I'm able to manage form a kind of amide. If you remember, like we discussed total four kind of mechanism. Curtius, Lawson, and that Hoffman, and then Esquimate reaction. That if you are having amide and you want to convert it to aniline only, okay, you know that what was the trick? That simply remove the CO, okay, like this. And now you will tell me what is the name of that reaction in which we are using only amide for the formation of amine. Yes, please. Yes, very good, Niharika. Hoffman bromide degradation there. So, okay, one thing strike in my mind that somehow if I'm able to manage amide, maybe I'm getting this amide. Okay, no, but it's a double bond. Then how to convert into a amide? So, let's go with ozonolysis. Okay, let's go with ozonolysis. So, let's go with the oxidative ozonolysis. Okay, why oxidative? So that we are getting a acid there because we want amide, and amide is only possible with the acid. So oxidative ozonolysis means if I'm using ozone with the water only or H2O2, so it's oxidative ozonolysis. Ozonolysis. Okay, so means one carbon less now, so one carbon, two carbon, four carbon, and this is a CO, and this is OH, acid form, and one is the. Let me just erase this. Okay, so we are getting one is the formic acid and one is this one carbon, two carbon, three carbon, four carbon. It's a butanoic acid. Okay, the step number two. We want amide, right? So the step number two, let's just go with SOCl2. Okay, so that's why that in organic chemistry, every chapter is important. Okay, maybe we are dealing with the mind and maybe we are getting some concept from the previous classes. So what does it? Remember that if I want to convert acid into the acyl chloride, how to go? You can use SOCl2, you can use PCl3, you can use POCl2, even you can use PCl5 as well. Okay, but this is one of the best method because in this case both are the gases. If you remember, SO2 is also the gas and HCl is also the gas. So both is going to evolve. That's why we have to prefer the use of the SOCl2 for this kind of purpose. Anyway, next one carbon, two carbon, three, and okay, CO, and this is Cl. So we are getting right now that is acyl chloride. Again, you can even count the number of carbon, one carbon, two carbon, three carbon, four carbon. Just make sure that carbon is very much important. Do not miss any carbon. Every time use the carbons. Sorry, number for the carbons. Next step we just discussed, right? That we can directly use the ammonia. Okay, we can directly use the ammonia. If you remember in the previous class we discussed about if I'm using ammonia, ammonia is a lone pair, and even we just discuss about the same thing. Ammonia attack here, this is how the bond open, this is how the bond close, and chlorine is going to leave. Okay, so next step, that one, two, three, okay, and this is a CO, and now I'm getting amide. And after that you can go with simply that is the Hofmann bromide degradation. What was the reagent? Bromine. 4 NaOH. Remember 1 ratio 4. So it's a Hofmann bromide degradation, and this is how the step we are going to follow. If you know any other method, please go. Okay, it's not like, ma'am, no, we can't go with the ozone. It's totally your choice. Okay, in this case, we can use different kind of reagent. I can use even HiO4. HiO4 also do the same type of reaction. It's going to break the bond at OH both side, and at the end we end up with the same thing. Okay, so you can use any reagent. Even you can use that as a KMnO4. Okay, that acidic KMnO4. If you remember, if I'm using only alkaline or neutral, we are getting diol. Otherwise, if I'm using acidic KMnO4, this double bond is going to break. Okay, so any method you can apply. It's totally your choice. So it's a step number one. Okay, it's a step number two. It's a step number three, and this is a step number four. So it's basically a four-step reaction. Okay, this is how. Okay, so I hope it's clearly visible now. Mm, wait. Okay, see this. So this is how you can convert the thing. Of course, Dashika, there is a so many way. As I already told you, you can use KMNO4, you can use HiO4, you can use any reagent. Even in this case, in this step, okay, let me just write all the possible reagent, or you can use acidic KMNO4. Okay, similarly in this step, you can use PCl3 or you can use PCl5. Okay, so many reasons, so many steps. Let me highlight this. This is the first, and this is the first. This is the second, third method. Similarly, this is the third. Okay, so you can proceed with any reagent. Okay, Dishika, is this point clear? Okay, so this is all for the conversion there. Now let's go further. Now, okay, this is all for the conversion. I guess it's enough about the conversion. Now let's start with the again the theory part. Okay, so let's start. So this part is done. So we just discuss about alkylation and acylation part. Let me just again go toward the chart what I'm discussing right now. Okay, so this is this part done. Alkylation, this part done. Acylation. Now let's talk about the third one, that is a carbyl amine reaction. Okay, carbyl amine reaction. So everything we're going to record. So let's discuss about that is a carbyl amine reaction. And again, it is one of the famous reaction. Okay, after that Hofmann bromide degradation. Next type of question asked from this topic. So it's a carbyl amine reaction. Okay then, so same that what was the substrate and everything. So let's start with this. First of all, primary amine. Primary amine, only primary amine. Later, this become a test as well for the detection of primary amine. That only primary amine give the carbyl amine test positive. So you can say that primary amine. Let me just write only primary amine. Okay, cool then. And how about the reagent? If I'm using the reagent here, so in this case we are using CHCl3 plus alcoholic QH. Can anyone tell me the same type of reagent we used in some reaction previously? What was the name of that reaction? Let me just give you a kind of hint as well. Uh, there we are having a kind of phenol. Okay, and I'm using the same CHCl3 and NaOH or KOH, and then we are getting this. Okay, why am I highlighting this reaction to you? Because the same type of mechanism we are going to discuss. Okay, so that you can recall something. What is the name of this given reaction here? Yes, Shiva, it's a Riemann-Tiemann reaction. So if this word came to the picture Riemann-Tiemann, so the first thing strikes should be in everyone's mind that carbon is intermediate. Carbon is a intermediate we are getting. What is carbon? Triplet, singlet, if you remember, right? So same thing we are going to use again. Okay, Riemann-Tiemann reaction is the name. Anyway, reason part is done. And how about the product? So in this case, this is the only reaction where we are ended with a different, unexpected kind of product, you can say. So what is the product here? Product is that is a isocyanide, or you can say that is a carbylamine. Okay, so that's why the name of the reaction is what? Carbylamine. Okay, what is the meaning of this word carbylamine? Okay, let's discuss about this. So anyway, let me just first write the general reaction. So how about the general reaction? That we are having a kind of primary amine. Okay, you can use anything. Okay, it's not like I'm using aniline, so you have to use the aniline. So like this. And in this case, we are using Cl3 again, plus that is the same alcoholic KOH. Okay, let me just write alcoholic here. Space was around there. Okay. So what is happening? That it is going to convert into this. If, you know, listen my point. Hofmann bromide amide degradation. is a kind of step where we are getting one less carbon amine. But in this case, if you're observing, if you want extra carbon, look at this. In this case, that this is extra carbon attacking here or attach here. So this is very, very, very much important part when we're dealing with the conversion again. Like we just discuss how to reduce the carbon, and if you want to increase the carbon, just go with carbolamine. Condition number one, primary amine have to be there. Okay, this is the basic condition here. And what is this basically? It's aniline. Okay, this is our aniline there. That's it. This is simple, sorted a kind of reaction. Look at this, how the reaction look like. Or like generally, if I'm talking, I can use any R. Okay, this is you can say example. And how about the general one? RNH2 we are using, and then CHCl3 and plus alcoholic QH. What is it? It's a chloroform, right? And then R, N, C. Isocyanide. This is isocyanide. Why this is isocyanide? Because look at this nitrogen connected with that carbon. So nitrogen part is combined here. So it's a isocyanide. Okay, this is general reaction. So again, that mechanism, every time that how to go with the mechanism. So let's discuss about the mechanism. So step number one, generation of carbon, same ditto, like the Riemann-Tiemann reaction. So let's talk about the mechanism. So let me just explain in a single line. Okay, again, you can use the same like formation of carbon. It's totally a choice. So let's see how. The step number one, generation of carbon. Okay, so step number one, that is the formation of carbon. Okay, let's see how. So carbon, three chlorine, hydrogen. We are using a base. Okay, this is a base. Okay, so OH simply attack on this hydrogen. Okay, and just because of this, what is really happening now? So water molecule remove. Okay, and then carbon. There is a negative charge. This is chlorine, and this is chlorine. Next step, that this negative charge simply attack here, and this chlorine leave the molecule. Okay, so we are getting a carbon. Okay, this is a kind of intermediate, and this is carbon. Quickly recall, and can you just tell me, is it singlet carbon or a triplet carbon? My question, the resulting carbon which is generated here, this is triplet carbon or singlet carbon? Recall, it's exception. Generally, triplet carbon is much more stable. Okay, maybe you don't know what is carbon, right? So anyway, let me just quickly give you a brief. So quickly recall, this is a carbon. What is carbon? We are having a two kind, and this is a chlorine. This is chlorine. If two electron present be like this, so it's a triplet carbon, right? Why? Because the spin is half and half. So according to the spin multiplicity rule, that you can say 2 multiply with half plus 1, half plus half, the complete s, the total spin, half plus half, it's become 1. So let me just write the 1 here. So how much we are end up there? We are end up with the 3. So that spin multiplicity, it's a spin multiplicity formula, atomic structure. Spin multiplicity. Okay. Similarly, that how about the singlet carbon? If in the same box, both the electron present be like this in the same box. Okay, so two electron paired up, so half plus half minus half, it's become 0. So same spin multiplicity, that is 2 multiplied with 0 become 1, so it's become 1 only, so it's a singlet, that is a 1, singlet. Okay, so in this case, if you're observing, chlorine has a lone pair. Okay, chlorine has a lone pair. So generally, that both are the unpaired. It's a much one like stable one. So generally, triplet is stable just because of the less repulsion. But in this case, repulsion have to be there because the two member living in a same room. So obviously, the repulsion have to be there. But still, this is much more favorable here. What is the reason? The reason is very simple, because chlorine has a lone pair and this is a vacancy. If this kind of scenario there, so there's a chances of the back bonding. Okay, and just because of this extra plus point here, in this case, the singlet carbon is much more stable. Okay, why? Because if you don't know, carbon is a electron deficient species. Deficient how? Count the number of carbon. Sorry, electron, one electron, two electron, three electron, four, five, six. So in this case, you are having only six electron. It is a electron deficient species. It is not a electron rich species. Okay. So this is how you can simply go. So let's just back again. So which kind of carbon this is? This is singlet carbon. Okay. So anyway, name is not important. This carbon is important. Okay. Formation of carbon is ready now. So let's see the next step. That is obviously now our carbon going to attack on the amine. So nucleophilic attack on carbon. So the step number two, nucleophilic attack on carbon. Let's see how. That this is RNH2. Nitrogen has a lone pair. It's electron deficient, chlorine, chlorine. So every time rich one is going to move toward the, you can say, this deficient one. So it's moving here. Okay, this is how it's moving. And if it is moving, what we are end up this nitrogen. Just focus on a nitrogen only. So there is a hydrogen, hydrogen, carbon, chlorine, chlorine. It means this nitrogen has a basically that is positive charge, and carbon one less bond, so that's why in this case you can say in there is a negative charge. Okay, so what is happening now? Proton transfer. Proton transfer, like they are going to neutralize one another charges. So this is positive, this is negative. Carbon will be like, I'm taking your hydrogen so that you can neutralize. So let's see after proton transfer what is happening. This is nitrogen NH, and now carbon, chlorine, chlorine, and hydrogen. So this is basically the simple thing. You can write directly that simple proton transfer. That this hydrogen is transferred from the nitrogen to the carbon here. Okay, this is the first thing that is generated here. We are ready. Okay, now what is the next step there? And base come. Okay, where I to write the base? I'm sorry, I forgot about it. Okay, this is my video. So let's back again. So I'm using a base here. So about the base, we're using KOH. Again, base come. Let's write the OH. Okay, so this OH attack on a hydrogen. Okay, and this bond open up. Okay, what is happening? Water molecule remove. So that is the water molecule simply leave. Now we are left with nitrogen. Okay, this is R, and this is a double bond. Carbon, chlorine, and chlorine. Okay, carbon, chlorine, and chlorine. And wait, chlorine is going to leave. Okay, I missed one step. You have to be very careful when we are dealing these kind of step. Okay, I'm using a different color. Chlorine leave. Chlorine is leaving. So then there is a formation of HCl. Okay, so where we are, double bond, chlorine and hydrogen. So again, base come. I will explain this last step. I know it's little bit weird. So it's attack again, bond open up, and this chlorine leave again. So what is the final product? R, nitrogen, triple bond carbon, this. So our isocyanide is ready. Okay, I'm explaining this step again. Again, listen. So we are having R, N, hydrogen connected, and this is carbon, this is hydrogen, this is chlorine, this is chlorine. So what was the step? OH come, base come, attack here. This bond here, chlorine leave, because chlorine is a very good loving group. Okay, so the next thing, we're getting R, N, double bond now here, and carbon, hydrogen, and chlorine. Still there is a scope that again base come, attack here, bond open up, chlorine leave. So what is the next step? That is a nitrogen and triple bond carbon. So this is the last step, the generation of isocyanide. Okay, so maybe I guess it's look little bit not good. Okay, but this is how the step going on. Okay, and we are getting that is isocyanide. Okay, so this is the simple carbylamine test. There is some important part for this carbylamine test. This test is only positive for the primary amine. This test is never given by the secondary or tertiary amine, you can say. Okay, so let's just back again. So mechanism part is done. Okay, one more thing, like I guess I already told you, right? Let me just check. That is both aryl and alkyl both give this test positive. So general reaction, this is a step number one, formation of carbon, and this is a step number two. Sorry, this is triplet. This is a step number two. Okay, so the previous one is the step number one. This is a step number two. Take on a carbon. Done. This is how the carbylamine test look like. Okay, done with the test. If you want to note it the last step, you can note it down. Let me just check any kind of question. This one is the good one. Last question of the class. Okay, so basically this is a reagent NH2 double bond CN. I'm using CHCl3 and KOH, and in the step number 2 this is PDCH2. So you have to identify what is this P, okay, or the product or the question mark. So options are option number 1. This question require a very good knowledge about all the classes till now. Okay, I can't say this question is only from today's class. Okay, some concept of the previous classes we also applied here. So this is O, hydrogen positive charged. Option C. Okay, you can start. Okay, I'm writing the options only. Think about it, what is really going to happen. If it is not visible, I will change the position. Okay, wait. Let me just check is it visible or not. Okay, I guess it's visible, right? So, wait. Okay, this is OH. D, option D. Okay, now please answer the question. So everything is visible now? Yes, please. Last question of the class. Anyone? One part we just covered, right? Okay, see. So you're partially right. Still, one little bit part left. Okay, so let's see that how to solve the question. Okay, I guess you are done now. So listen my point. First of all, if you are having RNH2, so very basic knowledge of the reason we're using here, that if I'm using H2 or I guess platinum, right? Or this carbon is be like this is just representing activated charcoal, okay? So what is happening? Sorry, CN now. So it is going to convert into NH2. Be noted. Okay, I guess we already discussed this into the previous class. Okay, there I just remember that I'm using R directly and then I'm explaining no carbon you have to use. Right? Yes, Shiva. Yeah, you're right then. So let's back again. What is actually happening there? Just by observing aniline, and this is that CH and KH there. We just discuss about a reaction. What is the name of that reaction? We just discuss carbylamine test. Okay, so the step number one, that what is the point number one we are getting there? Let me just remove all the point now. Okay, so benzene, this is cyanide, CN. Okay, and this aniline is going to convert into the isocyanide. Okay, and double bond and H, I guess, right? No, it's not H. C is very simple. So now the next agent we're using here, that is H2 and PD, catalytic hydrogenation. So it's going to attack on this CN. So once it is going to attack, okay, so what is happening? There is a carbon and then nitrogen. So means I can write that is the carbon connected with nitrogen. This is how we are getting aniline because carbon part is combined, right? Like this. And then one more, that is this is CO group. It is going to convert into the alcohol is there. Okay, so next alcohol formation. Actually, this question basically check the basic knowledge of the reagent. Next, in this case, we just discussed that cyanide, but ma'am, isn't it the isocyanide? No, it's not an issue. Simple, if nitrogen part connected here and the carbon that side, so it's become CH3 and this is N, amine we want. Okay, so hence option D is the correct answer for this question. That's it. Okay, mechanism, no need. Okay, simple, option D is the correct just by using a basic knowledge of the reagents. Okay, this is all for the class. This is all for the reason. In the next class, we're going to discuss about the Hinsberg method. Okay, that how to detect primary amine. It means test part left, some azodie left. Okay, and then next class will be on Tuesday. Okay, actually, I have some work to do. Okay, so that's why. Just next class on Tuesday. Sorry for this. I know that syllabus is important for you, but still. Okay, so that's it. This is all from my side. So any problem, any issue still you are having, anything you want to ask, let me know. Otherwise, let's going to end the class then. Okay, so sorted, yes. So thank you so much then everyone for joining the class and have a nice day. Thank you. Okay, thank you so much.